All right, guys, in this video, we're going to do questions 21, 22, and 23. And this video will be based on combinations. Number 21 says, in a Powerball lottery, 5 numbers between 1 and 12 inclusive are drawn. When it says inclusive, that means we're including number 1 and then we're including number 12. These are the winning numbers. How many different selections are possible? Assume that the order in which the numbers is drawn is not important. Okay, let's start off first with labeling certain things. Number 1, the balls are distinct. That means they are different. Balls are different. Number 2, when you choose a ball, you do not repeat the ball. You do not replace it. So there's no repetition. No replacement. Zoom out a little bit. And number 3, it says, assume that the order in which the numbers are drawn is not important. So the order does not matter. Order doesn't matter. Because the objects are different, there's no repetition or replacement, and the order doesn't matter, we are using a combination. We have the combination. You have 12 balls in total between 1 and 12. And you're choosing 5 at random, and the order does not matter, and there's no replacement, and the balls are each different because they have a different number. The combination formula says the combination of n objects choosing R with no order being taken into consideration, that is n factorial divided by, let's rewrite the n factorial, the quantity of n minus r factorial times r factorial. So when it comes to this question here, the combination of 12 choose 5. That's 12 factorial divided by the quantity of 12 minus 5 factorial times 5 factorial. So 12 factorial divided by 7 factorial times 5 factorial. What we're going to do is we're going to expand the numerator until we reach the largest factorial in our denominator. So that's going to be 12 times 11 times 10 times 9 times 8. Stop at 7 factorial. Put that in blue. And the reason why we're stopping at 7 factorial is because there's a 7 factorial in our denominator. And we can simplify these two out. And after you simplify them out, expand the smaller one. 5 times 4 times 3 times 2 times 1. When we multiply 5 times 4 times 3 times 2 times 1, that is 120. Let's multiply our numerator. 12 times 11 times 10 times 9 times 8 times, well, no, that's it, times 8. Let's delete that. That gives us 95,040. So that's what's in the numerator. And we're going to divide this number by 120. Divide by 120. And that equals to 792. And that is the answer to the question. There are 792 ways to select 5 balls from 12 if there's no repetition, any order does not matter. Now we can also do this by using the combination feature in our calculator. To use the feature in the calculator, let's first put in the first number, which is 12. You're going to go to Math, go over to PRB, and this time you're going to choose option number 3, which is for a combination. Put in the second number, which is 5, and there you go. There's your answer of 792. So moving forward, I'm going to use the calculator features when I calculate my combinations. For this one, I just did it by hand. Number 22 says, a teacher has 20 boys and 10 girls in her class. In how many ways can she select 6 of the children to be in a play if she must choose 3 boys and 3 girls? All right. We want to find out how many ways to choose 3 boys and 3 girls. Let's ask ourselves the question, how many boys are in total? There are 20 boys in total. And we're choosing 3 boys. The order does not matter in how I choose my boys. It didn't say that I have to choose the boys first and the girls second, or vice versa, choosing the girls first and the boys second. It just says we're choosing 3 boys and 3 girls. And once a boy or a girl is chosen, they cannot be chosen again. Plus, boys and girls are distinct within each other. So when I choose one person, there is no repeating that same person because that person's already chosen. So this here is a combination. For the first one, it is a combination of having 20 boys. And you're choosing 3 when the order does not matter. When it comes to the girls, there are 10 girls in total. You're choosing 3 girls at random. 3 girls chosen. And the order does not matter in how you choose those girls. So that is the combination of having 10 girls, write that better, choosing 3, and there's no order. And the word and, when it comes to the fundamental counting principles, means to multiply. So you're going to multiply your combinations. So let's do that in a calculator. We're going to take the combination of 20 and 3. 20, choose 3. Order doesn't matter. And we're going to multiply that with the combination of 10, choose 3. And there is our answer. 1,368,000. No, I lied. 136,800 ways. And that is our answer for number 22. All right, let's do number 23. Number 23 says, in how many ways can a person select 4 books, 2 CDs, and 1 DVD from 10 books, 20 CDs, and 5 DVDs? Once again, this is a set of combination. We want to choose 4 books and 2 CDs and 1 DVD. We have 10 books in total. So 10 books. Let's write 10 books. You're choosing 4. And the order doesn't matter in how you choose your books or when do you choose the books, as long as you choose 4 books. So that is the combination of having 10 books, you're choosing 4, and the order does not matter. And means to multiply. So we're going to multiply here. 2 CDs. We have a total of 20 CDs. You're choosing 2. And the order does not matter in how you choose those 2 CDs. So that's going to be the combination of 20 CDs, choosing 2, order does not matter. And then we're going to multiply that with, we have a total of 5 DVDs. And we're choosing 1. And it doesn't matter which one that we choose or in the order that we choose it in. So that is the combination of 5, choose 1. And once again, the order does not matter. And now let's go ahead and calculate that. 10. Oops. Let's clear that. Let's go back. Hit math. 10. Choose 4. Let me double check. Yep, 10 choose 4. Times 20. Choose 2. Times 5. Choose 1. There's our results. 199,500 ways. All right, guys. Hopefully this video was helpful. You enjoyed it. You understand how to work with combinations. And I'll catch you in the next one. Take care.